Hi, on today's video we're going to take a closer look at those isosceles and equilateral triangles. So for our first one base angle in an isosceles triangle measures 64. What is the measure of the vertex angle? This is all vocab based of knowing what the different parts of a triangle are named as. Because it's isosceles, the first thing I know when I draw an isosceles triangle is that I have two sides that are congruent. When those sides are congruent, the angles across from them are also going to be congruent. And these right here are called base angles. We started talking yesterday that the sides that are congruent are called the legs, and the side that's not congruent is called the base, hence why these are going to be the base angles. So in an isosceles triangle, the two sides that are congruent are the legs. Across from those legs are congruent angles, and the one piece left that we haven't talked about is the vertex. So the one angle that's not congruent is the vertex, the one side that's not congruent is the base. So based on knowing what our pieces mean, we are told that one base angle is 64. So when I look at my isosceles triangle, these sides are congruent, these angles are congruent, and the base angle, if one base angle is 64, the other base angle is 64 as well. So if I want to find the vertex angle is the only angle we have left. It's the one angle that's not congruent to the others. If I know two of my three angles, I can do that by the triangle sum theorem. I know that all three angles in the triangle have to add up to 180. So we do 180 minus 64 minus 64. And we find that that vertex angle is going to be equal to 52 degrees. Right. Example 2. As we look at number 2, we can see that we have an isosceles triangle again. Although we're not starting with the fact that we have two legs congruent, when I see that these two angles are congruent, I know I'm going to have isosceles. In the last one, we went from the legs to the congruent angles. Now I'm going to start with the congruent angles. So if this angle is congruent, this side across, that means that these two sides are congruent. If the sides are congruent, I can set those two pieces equal to each other. This is a test question. This is a very big idea when it comes to isosceles of knowing that the angles across from the sides are congruent and the sides across from congruent angles are going to be congruent as well. When you have the three sides, it is going to be important to know which of the two sides you set equal. Because if I would have used 6x plus 7, I would have gotten a wrong answer because this side is not congruent to the other two. We move our 3x over. 22 is equal to 5x minus 13. We move 13 over. 35 is equal to 5x. And we divide and we find x is going to be equal to 7. Next one. As we read through, it is important maybe underline or highlight the different vocab words so we can concentrate on what we're doing. This time we have an equilateral triangle. So I think about what does equilateral mean? An equilateral triangle, what I know is that all three sides are congruent, and I know that all three angles are congruent. So we know that in this equilateral triangle, the perimeter is 18x minus 15. That means that side 1 plus side 2 plus side 3. When I add up the three different sides of the triangle, I end up with a perimeter of 18x minus 15. One of the sides is 4x plus 8. It doesn't say which one, and it really doesn't matter, because if this is 4x plus 8, then this is 4x plus 8, and this is 4x plus 8. Because in an equilateral triangle, all three sides are the same, it doesn't matter. They're all going to be 4x plus 8, which is going to help us with our equation. We can either write it as there's three sides of 4x plus 8. It takes those three sides equal the perimeter of 18x minus 15. Or you can just add the three sides 3 times. So 4x plus 8 plus 4x plus 8 plus 4x plus 8. It takes those three sides to give me my perimeter of 18x minus 15. Then we combine our like terms, or we distribute if we use the first one, to give us 12x plus 24 equals 18x minus 15. We move our 12x over. We have 24 is equal to 6x minus 15. We move our 15 over. 39 is equal to 6x. We divide by 6, and we find that x is going to be equal to 6.5. Number 4. In number 4, we want to find the value of y. As I look at my diagram, my indicators jump out at me that I have three sides that are congruent. But I want to find angle measures, so I have to think about the relationship between equilateral and equiangular. If it's equilateral, then it also has to be equiangular. And if it's equiangular, we know that all three angles are going to be 60 degrees. So to solve for this one, we have simply 5y plus 20 is equal to 60. This one angle right here has a measure of 60 degrees. We move our 20 over. 5y is equal to 40. We divide by 5, and we find that y is going to be equal to 8. Go ahead and turn over to the back side for one more problem. We are given triangle GHI is an isosceles triangle. Again, key, pay attention to the vocab words. HI is the base, that's important, which one is the base? And then we're given the lengths of HI, GI, and GH. So let's start by drawing our diagram. We have a triangle. It doesn't matter where we put G, H, and I. So I could put G, I could put H, I could put I, doesn't matter. Now as I read through, HI is the base. So if right here, if this is going to be the base of my triangle, that means that is the non-congruent side. That means GI and GH are the legs of the triangle. This is the base, and the legs of an isosceles triangle are congruent. We have that HI is the base with a length of 3x plus 6, and GI is 2x plus 14. GH is 5x plus 2. This is another really important question that's going to show up on your test. So when I read through this, it says sketch a diagram to represent the situation. Label everything that you know, including all sides and angles that you know to be congruent. So far, we labeled the two sides that we knew were congruent. Don't forget about the two base angles. The two base angles are also going to be congruent here. And last, set up an equation to solve for x. We're not going to solve, we just want to know which equations we would do. Now the legs are the congruent sides. So I pick the two pieces that are with the legs. Again, in this case, the base is not going to be part of our equation because the base is not part of our two equal legs. If the two pieces are equal, we set the two leg measures equal to each other, and then we would solve. We don't have to solve now, but we would solve if we were going to go ahead. All right, that's everything for more on equilateral and isosceles.